We are going to start now lecture 13 of chapter 10 class 11th mathematics straight lines. In this lecture we will talk about certain properties related to triangles. So the first definition we have over here, it is the definition of the centroid. We are talking about the centroid. So we are saying the point of intersection of the medians of a triangle, it is called the centroid of the triangle, and it divides the median internally in the ratio 2:1. So the first result we are going to prove over here, it is that if x1 y1, x2 y2 and x3 y3, these are the coordinates of the vertices of a triangle, then we have to prove that the coordinates of the centroid, they are x1 plus x2 plus x3 by 3 and y1 plus y2 plus y3 by 3. So we are saying that we are trying to find the midpoint over here. Suppose I am talking about this line AC. The coordinates of A are x1 y1, coordinates of C are x3 y3. So the midpoint over here, that will be x3 plus x1 by 2 and y3 plus y1 by 2. Similarly, we are saying if we are considering the vertices A and B, the midpoint over here we will have it is x1 plus x2 by 2 plus, or it is the y coordinate will be y1 plus y2 by 2. And similarly, the coordinates corresponding to this point D, this is midpoint of B and C. So the coordinates we have it is x2 plus x3 by 2 and y2 plus y3 by 2. Now if we look at the points, suppose I am talking about the point A and D, we want to find the coordinates of the point G, and we know that it is dividing it in the ratio of 2:1. So to calculate the coordinates of this point G, we are using the section formula, and result we will obtain, we are obtaining by using the section formula. We are saying these are the coordinates of the point G. These are the coordinates using the section formula, that it is being divided in the ratio 2:1, and these are the coordinates of these points. It is x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. Similarly, we are saying for the another part of the triangle, if we talk about BE, we are calculating the centroid. These are the coordinates. Similarly, for the third case, we have these are the coordinates of the centroid. So what we obtain is that the centroid we are talking about, it is common point. That is, common point means it is same corresponding to all the three sides and three vertices, and the centroid, it is given, the coordinates of the centroid, it is given by x1 plus x2 plus x3 by 3 and y1 plus y2 plus y3 by 3. So these are the coordinates of the centroid of a triangle whose vertices are x1 y1, x2 y2 and x3 y3. These are the coordinates of the centroid. Next we have to prove is centroid of the triangle obtained by joining the midpoints of the side of a triangle. A triangle is given to us. This is A, B and C. This is the triangle given to us. We are saying we have obtained another triangle by joining the midpoints. This is E, D, E and F. These are the three coordinates obtained from the midpoint of these 3 points. These are basically the midpoints of these 3 sides of the triangle. So we are talking about the centroid of the given triangle ABC and the centroid of this new triangle, we are saying DEF. We are talking about these two triangles, and we have to prove that centroid of both these triangles, they are same. So we are writing over here that the coordinates of these points, we are talking about this point D, it is A1 B1, E is A2 B2 and this F is A3 B3. These are the three coordinates that we have. And suppose we are saying that the coordinate of the point A, it is alpha comma beta. Now by using the points, suppose we are saying we are using the point A and F, we are calculating the value or the coordinates of the point B. This is midpoint over here, this is dividing it in the ratio 1:1. So the coordinates of the point B, it is given by 2a3 minus alpha comma 2b3 minus beta. So these are the coordinates of this point B, and if we use the coordinates of this point A and coordinates of the point E to calculate the coordinates of the point C, we obtain that the coordinates of the point C, they are 2a2 minus alpha comma 2b2 minus beta. These are the coordinates of the point C. Now if we use these three coordinates, we are talking about the coordinates of A, that is alpha comma beta, the coordinates of this point B are there, and the coordinates of this point C are there. These are the 3 points we are talking about. Now we are talking about these 2 points. One is the point B and second is the point C. We are talking about these 2 points. These points are there, and we are saying D is the midpoint of these two. So if we use these 3 points, we obtain that 2a3 minus alpha plus 2a2 minus alpha divided by 2, that is equal to a1. So this implies us that the value of alpha we will obtain, that is equal to a2 plus a3 minus a1. Similarly, using the y coordinates corresponding to these points, we obtain 2b3 minus beta plus 2b2 minus beta divided by 2, that is equal to b1. So again, by solving these values, we will obtain the value of beta is equal to b2 plus b3 minus b1. So this is value of beta and this is value of alpha that we have. Now by using these values of alpha and beta in these given points, we obtain that the coordinates of the point A, they are a2 plus a3 minus a1 comma b2 plus b3 minus b1. We are talking about alpha and beta. Similarly, the coordinates of the point B, we are saying they are of this form. When you substitute the value of alpha and beta over here, you will obtain the coordinates corresponding to the point B, and the coordinates corresponding to the point C, we obtain they are in this form. It is a2 plus a1 minus a3 and b2 plus b1 minus b3. So these are the coordinates of the points A, B and C. Now by using these three coordinates, we can calculate. We are talking about these 3 points. We have A, B and C. If we calculate the centroid of the triangle using the formula for the centroid, we obtain that the answer we obtain, the final answer we obtain, it is in the form a1 plus a2 plus a3 by 3 comma b1 plus b2 plus b3 by 3, and this is same as the centroid of the triangle given by vertices a1 b1, a2 b2 and a3 b3, and this is what we have to prove. So from the previous result, we can obtain the following results. First is, if the midpoints of the sides of a triangle are x1 y1, x2 y2 and x3 y3, then the coordinates of that triangle, they are given by x2 plus x3 minus x1, y2 plus y3 minus y1, then it is x3 plus x1 minus x2 and y3 plus y1 minus y2, and third coordinate it is x1 plus x2 minus x3 and it is y1 plus y2 minus y3. The second result we can obtain from this, it is, if two vertices of a triangle are x1 y1 and x2 y2 and the coordinates of the centroid are alpha and beta, then the coordinate of the third vertex are given by these coordinates. It is 3 alpha minus x1 minus x2 and the y coordinate it is 3 beta minus y1 minus y2. And the third result we can obtain from this, it is that the two triangles ABC and DEF, they are similar to each other. We are talking about the larger and the smaller triangle. And if we calculate the area of triangle ABC divided by area of triangle DEF, and we substitute the values of these lengths, we obtain that this ratio is 4. So we are writing that the area of the triangle ABC, it is 4 times area of triangle DEF. That is, the area of triangle is 4 times the area of triangle formed by joining the midpoints of its sides. Now the next question we have is, if D, E and F are the midpoints of the side BC, CA and AB of a triangle ABC, these are the sides given to us. This is A, this point it is B, and this point it is C, and it is being given that D, its coordinates are -2, 3, E, its coordinates are 4, 3, and F, its coordinates are 4, 5. These are the midpoints of these three sides. Then we have to find square root of AG square plus BG square minus CG square square root, where G is the centroid of triangle ABC. So these midpoints are given to us. The coordinates of these three midpoints, they are given to us. So from these three coordinates we can find the coordinates of the point A, B and C. So the coordinates, we can use the previous formula to calculate the value of alpha and beta, and we can see that the value of these coordinates A, B and C, we are using the formula to calculate the value of alpha and beta, and we have calculated the coordinates of the point A, B and C. Now we can calculate the coordinates of the centroid, and the coordinates of the centroid, either you can use the coordinates of triangle ABC or you can use the coordinates of the triangle DEF. We are talking about this triangle DEF. You can use coordinates of any of these triangles to find the coordinates of the centroid, and the coordinates of the centroid we obtain it is 2, 5. So these are the required points. Now we have the coordinates of the point A, we have coordinates of the point B, we have coordinates of the point C, and we have coordinates of the point G. Now by using the result, the distance formula, we can calculate the length AG. It is square root of this value, we have it is square root of 10 minus 2 square plus -1 minus 5 by 3 square. The answer we get it is 8 by 3 square root 10. Then we are calculating the value of BG. It is 4 by 3. By using the distance formula, you will get it is 4 by 3 square root of 58. And last we are saying it is CG. The answer we get it is 4 by 3 square root of 34. So if we substitute the values in this formula, the required value, we are saying it is square root of AG square plus BG square minus CG square, and we substitute these values over here. We have substituted these values over here. We obtain the final answer by solving these values. We obtain the final answer as 32 by 3. This is the final answer we obtain in this case. So this is how we can apply the previous results to solve the problems. Next is, if G is the centroid of triangle ABC and O be any point in the plane of the triangle, we are saying we have a triangle ABC and G is the centroid of this triangle and O is any point in this triangle, then we have to show that OA square plus OB square plus OC square, that is equal to GA square plus GB square plus GC square plus 3 times the distance between G and O square. This result we have to prove. So to solve this problem, we are considering, let the point G, that is the centroid of this triangle, it is at origin, and this, if this is the origin, we are considering, suppose these are the x-axis and the y-axis, this is the point G, and the point O, it lies on the x-axis. This is the point O. So the coordinates of this point will be of the form a, 0. We are talking about any triangle over here. The triangle may be of this form. We are saying this is the triangle that we have. So this is the A, this is B, this is C. Now this length, OG length, we are saying this is A. If the coordinates of this point A, it is x1 comma y1, coordinates of the point B, it is x2 comma y2, and coordinates of the point C, it is x3 comma y3, and we are calculating the value of the length OA plus OB square plus OC square. We obtain, if we calculate this length, it is x1 minus A square plus y1 square plus x2 minus A square plus y2 square plus x3 minus A square plus y3 square. This is the value of OA square plus OB square plus OC square. And if we open all these terms, we will obtain the answer in the form, it is x1 square plus x2 square plus x3 square. Then the terms we have, it is y1 square plus y2 square plus y3 square. Then we have minus 2a into x1 plus x2 plus x3, and last we have it is plus 3a square. Now G is the centroid of this triangle, and the coordinates of this centroid, it is x1 plus x2 plus x3 by 3 comma y1 plus y2 plus y3 by 3, and these values, these are equal to 0. So we get x1 plus x2 plus x3 is 0. This term we are saying it is equal to 0. So this result becomes, this is equal to sigma x1 square plus sigma y1 square plus 3a square. This is the value of this term. Now if we calculate the value of this side, it is GA square. So G is the origin, this point it is x1 y1. So the answer we will get for this, it is x1 square plus y1 square. Next it is plus x2 square plus y2 square. Next it is plus x3 square plus y3 square, and the last term we will get, it is GO, the length GO we have, it is A. So we get it is plus 3 times A square, and we can see that both these values, this value and this value, both these values, these are equal. Both these values are equal, and this is what we have to prove in this question. Now the next question we have is, if G is the centroid of triangle ABC, G be the centroid of triangle ABC, we have to show that AB square plus BC square plus CA square is equal to 3 times this value. So again we are considering, suppose this point B, it lies at the origin. The coordinates of this point C, it is a comma 0, and coordinates of this point A, it is h comma k. Then the coordinates of this point G, they will be given by h plus a by 3 comma k by 3. These are the coordinates of the point G that we have. Now if we substitute the values in this formula, we are saying it is AB square. So AB square, it is h square plus k square. Then it is BC square. The length of BC, it is a square, and last we have it is CA square. So CA square is a minus h square plus k square. So this value we will have, it is h square plus k square plus a square plus h square plus h square plus k square minus 2a h, and the value comes out to be 2 times h square plus k square plus a square minus 2a h. Now if we try to solve the right hand side of this equation, if we solve the right hand side of this equation, we have 3 times GA square plus GB square plus GC square. So if we calculate the length GA square, it is h plus a by 3 minus h whole square plus k by 3 minus k whole square. Next will be h plus a by 3 square plus k by 3 square, and the third value we will have, it is plus h plus a by 3 minus a square plus k by 3 square. So we are saying if we solve these values, the final answer you will obtain it is in this form. This answer we are getting, and this is same as what we have obtained for the left hand side. So both these values, these are equal to each other. So we have proved this result, that AB square plus BC square plus CA square, that is equal to 3 times GA square plus GB square plus GC square. The next question we have is the vertices of a triangle are 1, 0, 2b and c square minus 3. We have to prove that the centroid cannot lie on the y-axis, and we have to find the condition that centroid may lie on the x-axis. So if we calculate the centroid for this triangle, we have the coordinates, it is 1 plus 2 plus c square divided by 3 and a plus b minus 3 by 3. These are the coordinates of the centroid. If centroid has to lie on the y-axis, so we are saying that this part should be 0. So we are getting it is 3 plus c square by 3 should be 0. So this implies us that c square should be equal to minus 3. And for the real plane, this thing is not possible. So we are saying that the centroid cannot lie on y-axis. In the second part, we are saying the condition for the centroid to lie on the x-axis, it is a plus b minus 3 by 3. This should be equal to 0. So this implies us that a plus b should be equal to 3. So this is the condition that we have, that a plus b is equal to 3. This is the condition that the centroid may lie on the x-axis. Now the next definition we have, it is in center of the triangle. So we are saying the point of intersection of internal angle bisectors of a triangle, it is called the in center. Now suppose we have a triangle whose coordinates, vertices of the coordinates, they are a, b and c, and they are x1, y1, x2, y2 and x3, y3, and we have to prove that the coordinates of the in center, they are given by, these are the coordinates of the in center, that is ax1 plus bx2 plus cx3 divided by a plus b plus c, and second y coordinate, it is a y1 plus b y2 plus c y3 divided by a plus b plus c, where these a, b, c, small a, b, c are the lengths of sides bc, ca and ab respectively. Now we know that if we look at this vertex a and we are talking about this AD is the angle bisector, then we know that the bisector of the angle of a triangle divides the opposite sides in the ratio of the sides containing the triangle. So we are talking about, if we are talking about this triangle, this vertex A, we are talking about these two sides, one is AB and one is AC. The length of this side AB we have, it is C, and the length of this side AC, it is B. So we are saying that this BD and DC, these will be divided in the ratio C is to B. So if we have to calculate the coordinates of this point D, we are using the result that this side, it is being divided in the ratio, we are saying this BD is divided in the ratio C is to D. So the coordinates of this point D we can calculate. The coordinates of this point D, they are given by Cx3 plus Bx2 divided by C plus B, and this y coordinate, it is given by Cy3 plus By2 divided by C plus B. Now consider this line BDC. If we consider this line, we are saying the ratio DC is to BD, that is equal to B by C, and if we add 1 on both sides, we obtain BD plus DC divided by BD, that is equal to B plus C by C. Now this BD plus DC, it is this length BC, and this whole length is equal to A. So we obtain A by BD, that is equal to B plus C by C. So we obtain from this that the value of BD we have, that is equal to AC by B plus C. So we have obtained this value, BD is equal to AC over B plus C. Now if we talk about the triangle ABD and BI is the bisector of side B of this angle B, it is the bisector of angle B. So we have AI over ID, that is equal to AB over BD, and this gives us that C over AC by B plus C, that is equal to B plus C over A. Now we are saying that I divides AD in the ratio B plus C is to A. So we obtain, by using this result, we can obtain the coordinates of I. These are the coordinates of I we are saying, because it is dividing it in the ratio B plus C is to A. So these are the coordinates of the point I that we have. So similarly, we can divide BE internally in the ratio C plus A is to B, and from this we can find the coordinates corresponding to this point. These are the coordinates we have obtained. These coordinates, these are same. These coordinates, these are same. So, and similarly for the third case, we can obtain the coordinates corresponding to the third side, and we can see by combining all these results that the point we are talking about, the three angle bisectors that we have, they meet at the point I, whose coordinates are given by this formula. And this point I, this is called the in center of the circle. So we have to prove two things. One is we have to find the formula for the in center, and second, we have proved that the three angle bisectors that we have, they are concurrent. They meet at a point whose coordinates are given by the in center of the circle. Now the next question we have is, if ABC is an equilateral triangle, this is given to us. That is, all the three sides they are equal, A is equal to B is equal to C. So we have to prove that the in center and the centroid of the triangle, they will coincide. Now we know that for an equilateral triangle, the angle bisector and the median, they are same. So what we obtain from this, we can directly claim from this that the in center and the centroid, they will be same, and they are given by this result. Now the next question we have is, find the coordinates of the in center of the triangle whose vertices they are given by these 3 points. So to apply the formula, we know that the in center, it is given by AX1 plus BX2 plus CX3 divided by A plus B plus C. This is the x coordinate, and similarly y coordinate. We are saying in center is x comma y. So we require the values of A, B and C, that is these three lengths A, B and C. So to calculate these lengths, we are using the distance formula over here. The length corresponding to this side C, we have it is 6 root 2 units. The length corresponding to the side A, we have it is 5 root 2 units, and the length corresponding to B, we have it is 5 root 2 units. These are the lengths we have calculated using the distance formula and using these 3 points A, B and C. Now if we substitute these values in this result, we obtain the values of the in center, or the coordinates of the in center, as we are getting the value of x as AX1 plus BX2 plus CX3 by A plus B plus C. On solving this, we will obtain the final value in the form 5 by 2, and by substituting the value of A, B, C and x1, x2, x3 in the y coordinate, we obtain the value is 5 by 2. So we are saying that the in center of this triangle, that is given by the coordinates 5 by 2 comma 5 by 2. These are the coordinates of the in center of the triangle. Now the next question we have is, if these are the coordinates of the midpoints of the sides of a triangle. So we are talking about, this is the coordinate 3 by 2 comma 6, this point D it is 3 by 2 comma 0, and this point F it is minus 1 comma 6. These are the three coordinates given to us, and midpoints, these are the midpoints of these three sides. Then we have to find the centroid of the triangle, and we have to find the inner center of the triangle. So if we are considering that the coordinates of this point A, it is alpha comma beta, this is the midpoint over here, and we have to calculate the coordinates of the point B. So what we will have, the coordinates, say the coordinates of this point B, they are A comma B, then what we will have is A plus alpha by 2, that should be equal to minus 1. So this implies us that the value of A we have it is minus 2 minus alpha. Similarly, for the y coordinate, we can substitute the value, and what we are obtaining from this is, we are saying the coordinates of the point B we are getting, it is minus 2 minus alpha comma 12 minus beta. And similarly, if we calculate the coordinates of the point C, we are using this point A as alpha beta, we have this is the midpoint of A and C. So if we calculate the coordinates of the point C, we are getting the value as C is 3 minus alpha comma 12 minus beta. But midpoint of BC, we are talking about, we have the coordinates of this point B. This point we have it is minus 2 minus alpha comma 12 minus beta. Coordinates of this point C, we have it is 3 minus alpha comma 12 minus beta. Now using these 2 points, if we calculate the midpoint over here, the answer we are getting, we are saying the midpoint we have it is 3 by 2 comma 0. So what we get from this is that 3 by 2, that is equal to 3 minus alpha plus minus 2 minus alpha by 2. So when we solve this value, we will obtain the value of alpha is equal to minus 1. Similarly, for the y coordinate, we will obtain the value of beta is equal to 12. So we have obtained this value. So the coordinates of the point A, we get it is minus 1 comma 12. Coordinates of the point B, by substituting the value over here, we will get it is minus 1 comma 0, and the coordinates of this point C we will have it is 4 comma 0. So these are the three coordinates of the points A, B and C of this, the vertices of this triangle ABC. Now when we have to calculate the centroid, we are using the direct formula over here. We know that the formula for centroid it is x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. So substituting these values over here, we obtain the coordinates of the centroid as 2 by 3 comma 4. These are the coordinates of the centroid of this triangle. And when we have to calculate the inner center, we are calculating the length BC, we are calculating the length CA, we are calculating the length AB. We have calculated the length of all these three sides. It is 5, 12, 13 and 12, and we have substituted the value in the formula for the inner center of the triangle. We know the formula for the inner center of the triangle. We have substituted these values, and we obtain that the final answer we obtain it is 1 comma 2. Now in this next question, we are given one vertex of the triangle, it is 1 comma 1. This is the vertex A we are saying, 1 comma 1, and the coordinates of the midpoint of the two sides of the triangle through this vertex we are saying. This coordinates of this midpoint it is minus 2 comma 3, this is given. Coordinate of this point it is E, it is 5 comma 2, this is given. Then we have to find the centroid and inner center of the triangle. So again, if we consider the coordinates of the point B, suppose I am talking about this coordinates of this point B, we are saying say it is A comma B. Then what we will have? We will have minus 2 is equal to, this is midpoint over here, that is equal to A plus 1 by 2. So this implies us minus 4 is equal to A plus 1. So this implies us A is equal to minus 5. For this point B we are saying, we will have B plus 1 by 2 is equal to 3. So this implies us B is equal to 5. So coordinates of this point B we will have it is minus 5 comma 5. Similarly, the coordinates of this point C we can obtain it is 9 comma 3, and by using these 2 points, we are saying by using the point B and C, we can obtain the coordinates of the point D as 2, 4. So we have the vertices of this triangle we have obtained. A is 1, 1, B is minus 5, 5 and C is 9, 3. So using these three vertices we can obtain the centroid of the triangle. And to find the incenter, we have calculated the length. We are saying this A is length of BC, that is 10 root 2. Similarly, we have calculated the length CA. Similarly, we have calculated the length AB. We have calculated all these lengths. And using the formula for the incenter, we can obtain the coordinates of the incenter in this form. These are the coordinates of the incenter of this triangle. Now next we have is, let G be the centroid and I be the incenter of a triangle with vertices A, B and C. And it is being given that the distance between the centroid and the incenter, it is 25 by 3 square root of 205 times lambda. And then we have to calculate the value of lambda. We have to find the value of lambda. So we are saying, first thing we are going to calculate is, from these three coordinates we can calculate the coordinates of the point G. We are using the formula x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3, and we will obtain the answer as 16 by 3, 2. These are the coordinates of the centroid. Next we are saying we have to calculate the value of I, coordinates for the I. The formula we know, and for that formula we require the length A, that is length of side BC, length of side CA and length of side AB, and the answer we have, it is 25, 39 and 56. These are the lengths of the side BC, CA and AB. And using these three lengths we can obtain the coordinates of the incenter of the triangle. These are the coordinates. By using this formula we can obtain that the coordinates of the incenter, they are minus 1, 0. So we have obtained the coordinates of the centroid G. We have obtained the coordinates of the incenter. Now we can calculate the value Gi, the length Gi. We use this formula and we obtain the answer as, it is square root of 205 by 3. These are the coordinates we have obtained over here, and it is being given that this length Gi, it is 25 by 3 square root of 205 times lambda. So we are saying that both these values are equal, and this implies us that the value of lambda we have, it is 1 by 25. This is the value of lambda that we will have. So what we have done, we have calculated the centroid using the formula. We have calculated the incenter by using the direct formula. From these two, from incenter and the centroid, we have used the distance formula to calculate Gi, and then we have compared it with the given value to obtain the value of lambda. Now the next term we will have over here, it is x centers of a triangle. So we are saying, suppose we have a triangle and we are talking about the point of intersection of the external bisectors of the angle of a triangle. So we are considering a triangle over here. This is the triangle ABC. We are saying this is the point A, this is the point B, and this is the point C. We are talking about the external bisectors. We are saying these two sides we have extended like this, these two sides we have extended like this, and these two sides we have extended like this. Now if we talk about the external bisectors, we are saying for this side, this vertex B, we are drawing, this is the external bisector we have. For this side C we have, this is the external bisector. For side A, if we draw the angle over here, this is the external bisector that we have. So the points where these external bisectors they are intersecting, we are saying this is the point I1, this is the point I2, and this is the point I3. These are the 3 points that we have, and these are the 3 x centers of the triangle. And with this point I as the center, if we draw these three circles we are talking about, we are saying we will obtain the circles. These are shown in the figure over here. We are talking about, this is the circle with center I, this is another circle with center I2, and this is the circle with center I3. These three circles that we have drawn with these centers I1, I2, I3, these are called the circle opposite to the vertex A is called the ascribed circle opposite to A. So these are the two terms we have. One is X center, and the corresponding circles we have, they are the ascribed circles. And as we have already seen that the coordinates of these points I1, I2, I3, the coordinates of these 3 points we will have, these are the formulas we will have for I1, I2 and I3, where these are the lengths. So these are just coming from the formula of the external bisector that we have already seen in our previous lectures. So based upon this we have the following problem. So it is, if the coordinates of the midpoints of the side BC, CA and AB of a triangle, these are the coordinates of the midpoints given to us, then we have to find the X center opposite to the vertex A. So first thing we are saying is, these are the coordinates of the midpoint. This is the point D, this is the point E, and this is the point F that we have. Now from these 3 points we can calculate the vertices of the triangle. If we consider that the vertex A is alpha comma beta, then by using this point F we can calculate the coordinates of the point B. By using this point E, this is midpoint over here, we can calculate the coordinates of the point C. And now we will obtain the coordinates of the point B that we will obtain. It will be 6 minus alpha comma 8 minus beta by using the midpoint formula. The coordinates of the point C we will obtain, it is 4 minus alpha comma minus 6 minus beta. And now by using these 2 points, by using C and B, we can calculate the midpoint over here. That will basically equal to this point D, and we will obtain that the value of alpha we have, it is 4, and the value of beta we have, it is equal to 0. So these are the value of alpha and beta. So by substituting these values we obtain that the coordinates of the point A that we will have, it is 4 comma 0. Coordinates of the point B we have, it is 2 comma 8, and coordinates of this point C we have, it is 0 comma minus 6. These are the 3 coordinates we have. Now by using the distance formula we can obtain the lengths of the side AB, BC and CA. We have used the distance formula to calculate the length of the side A, B, B, C and C, A. These are the 3 sides we have calculated, and by substituting these values in the formula for the X centers, we have obtained the values, the coordinates of the X center opposite to A. We have substituted this values of A, B, C, X1, Y1, X1, X2, X3, Y1, Y2, Y3 in these formulas, and we obtain the final answer in this form. So these are the coordinates of the X center opposite to the vertex A corresponding to this triangle. The next definition we have, it is the circumcenter of a triangle. So circumcenter of the triangle is the point of intersection of the perpendicular bisectors of the side of a triangle. So we are saying that this is the triangle we have, it is ABC. This is the triangle we are talking about, and the perpendicular bisectors of side BC, it is OD. Perpendicular bisector of AC, it is OE, and perpendicular bisector of AB, it is FO. These are the 3 perpendicular bisectors of the side, and the point where these perpendicular bisectors meet, this is the point O we are talking about, and this is called the circumcenter of the triangle. And the formula for the coordinates of this circumcenter, this formula you can remember as it is, and you can use this formula in your problems. So it is given by x1 sine 2a plus x2 sine 2b plus x3 sine 2c divided by sine 2a plus sine 2b plus sine 2c. Similarly, this is the y coordinate that we have, and the corresponding formula for, if we use the angle in terms of cos, it is given over here, and this A, B, C, small a, small b and small c, these are the lengths of the side. the length of the side AB, it is small c. So this formula you can remember. Now based upon this we have the following problem. So it is in a triangle ABC with vertices. A has the vertex 1, 2, B has the vertex 2, 3 and C has the vertex 3, 1. Angle A, angle B, these are equal to cos inverse of 1 by square root 10, and angle C, it is cos inverse of 4 by 5. Then we have to find the circumcenter of ABC. So from these values, we are talking about the value angle A is equal to angle B is equal to this. We can calculate that cos of angle A, that is equal to cos of angle B, that is equal to 1 by square root of 10. And from this value we can calculate the value of sine of A and sine of B. These are the values of sine A and sine B. Similarly, we can calculate the value of sine C. And from these values, from the value of sine A, cos A, we can calculate the value of sine of 2A, that is equal to 2 sine A cos A. So these are the values we are using over here. So we get the values as the value of sine 2A. The formula we have, it is we require the value of sine 2A sine 2B, it is 3 by 5, and we have obtained the value of sine 2C, that is equal to 24 by 25. So by substituting these values in the formula, we are talking about this is the value of x that we have, this is the formula that we have. By substituting this value in the formula, we obtain the value of x is equal to 13 by 6, and by substituting it in the value of y, the formula for y coordinate, we are saying the value we obtain, it is 11 by 6. So we are saying the coordinates of circumcenter are 13 by 6 and 11 by 6. These are the coordinates of the circumcenter that we have. So these are the two more formulas given over here. First is for the case if the angles of the triangle ABC are not given and we have to calculate the circumcenter. We are saying these are the coordinates given, A, B and C. These are the coordinates given to us. Then the circumcenter, it is given by this formula. It is x1 plus x2 plus lambda times y1 plus y minus y2 divided by 2. And the y coordinate, it is given by y1 plus y2 minus lambda times x1 minus x2 divided by 2. And to calculate the value of lambda, to find the value of lambda, we will look at this matrix P. It is x1 minus x3, x2 minus x3. This is y1 minus y3, y2 minus y3. These are the coordinates over here. And we are talking about this is the first row and this is the second row that we have. And the value of lambda, it is given by row 1 dot row 2 divided by determinant of this matrix P. So this formula you can use to calculate the circumcenter when the vertices of the triangle are given and the angles, it is not known. Next is in the second case, we are saying if the angle C is given instead of coordinates of the vertex C and the vertices A and B, they are given. We are saying in this case it is being given that this vertex A, it is x1 comma y1, this B, it is x2 comma y2, and this angle C is given. These three values are given to us. Then we use the formula in this form. This is the formula for the circumcenter of the triangle. So these are the direct formulas that you can remember to solve the problems. So the problem based upon these formulas, the first one we have is find the circumcenter of the triangle whose vertices are 2, 2, 4, 2 and 0, 4. So these are the three vertices given to us. So first of all, we have calculated the matrix P. It is given by x1 minus x3, y1 minus y3, and this is x2 minus x3, this is y2 minus y3. So if we calculate these values, the answer we obtain, it is 2 minus 2, 4 and minus 2. These are the values we have. It is x1 y1, x2 y2, this is x3 y3. We have substituted these values over here. We obtained this matrix P. So we are talking about row 1 vector. This is basically 2 and minus 2. Row 2 vector, it is 4 and minus 2. If we calculate row 1 vector dot row 2 vector, the answer we obtain, it is dot product over here, it is 8 plus 4, that is equal to 12. And determinant of this matrix P, it is 4. So answer we are getting, it is 3. So the value of lambda we obtain, it is equal to 3. Now the circumcenter, it is given by the formula. This formula we have already seen. So if we substitute these values of x1, x2, y1, y2 and lambda in this formula, we obtain that the circumcenter of this triangle, it is 3, 5. So this is how you can apply the formula we have studied in our previous slide. Next is find the circumcenter of the triangle ABC if A is equal to 7, 4, B is equal to 3, minus 2 and C is equal to pi by 3. So in this case we are given two vertices A and B. These are given to us, and we are being given an angle C, that is equal to pi by 3. So we are using the formula. It is x1 plus x2 plus minus cot of C times y1 minus y2, and the y coordinate, it is given by y1 plus y2 minus plus cot of C x1 minus x2 divided by 2. So if we substitute these values over here, if we substitute these values in this formula, we obtain the final answer as, we are saying either this is the circumcenter of the triangle or this is the circumcenter of this triangle. So in this case we are getting two circumcenters because we are talking about, so this is the coordinate plane we are talking about, and we are talking about a point, it is 7, 4 and second point it is 3, minus 2. This is the point A, this is the point B. So we can have two triangles over here. Either the triangle can be in this form where this angle, it is pi by 3, or the triangle can be over here. This angle we have again, this is pi by 3. So we have two triangles over here. So for one triangle, the coordinates given over here, this will be the circumcenter. For this second triangle, this will be the circumcenter, and this is the reason why we are getting two answers in this case. The next term we have is the orthocenter of a triangle. So we are saying the orthocenter is the point of intersection of the altitudes. That is the line through the vertices and perpendicular to the opposite sides. So if A has the coordinates x1, y1, the vertex A, B has the coordinates x2, y2, and C has the coordinates x3, y3. These are the vertices of the triangle ABC. Then the coordinates of the orthocenter, they are given by this formula. So these results you can remember as it is. We are not going into the details of the proofs of these formulas. You can just remember these formulas